Hey everybody, around 13 years ago, this fascinating problem type came up at the Singapore Mathematical Olympiad. I liked it so much, I've reworked it with different constants. Now, the scary thing about the problem is that this part right here is a very strange looking initial condition, but with some manipulation, this will end up being a quadratic expression equals a constant. And notice we have a quadratic expression right down here. All right, so we can use this quadratic expression equal a constant to manipulate to get this part to actually be a constant. So that's kind of the way to look at this problem, or one way to look at this problem, maybe the only way. Now, it's easier to handle it via long division. I didn't show you the steps of the long division, but our original problem, we have a quadratic quotient and then a divisor and then a linear remainder here after you do the long division. I did not show those steps, all right? Now the goal again is this is going to turn into a favorable constant if we can manipulate this initial condition. So the initial condition, here it is. And the key aspect of it is recognizing that this surd is actually a perfect square. If you just take a look here, a plus b quantity squared, this would give you 25 plus 11, which is where this 36 comes from. And then 2 times 5 times 11 is this. So you actually get that this is, you can make it, write it as a squared expression. That removes the square root, and then you get this nice result right here. And notice what's going on right here. This is in the form a plus b, a minus b. And this is a standard surd conjugate trick. But a plus b right here, and then a minus b here. And that, of course, gives you a squared minus b squared, but that's actually 14. Right, that's actually 14 because you have 5 squared, which is 25 squared, 11 squared is 11, 25 minus 11 is 14. So you see how all of this just cancels out. This is 14, all of this is 14, and you just end up with this, and that's the answer to the y question. Okay, so we end up with x is equal to just this, which is, that's quite a bit of progress if you look at the initial condition. Okay, now it actually solves out fairly nicely at this stage. If you subtract 5 from both sides and square, you see x minus this 5 is what I've written down right here. And when you square it, you square minus the square root of 11, which gives you 11. Okay? So you see this is pretty favorable because we know that x squared minus 10x plus 25 is equal to 11, but we need to know what x squared minus 10x plus 17 is. But notice right here that this would imply if you just subtract 8 from both sides, this gives you x squared minus 10x. Okay, minus 10x, and again, you're subtracting 8 from both sides, plus 17 equals to 3. And this is the magic of the problem right here. This is why this crazy looking thing even works. Okay, again, folks, we know this to be a fact from the initial condition, right? But we need this. We don't need this. We need this, right? X squared minus 10x plus 17. So again, what I did, subtract 8 from both sides. That'll give us the 17. Subtract 8 from 3, and you 8 from 11, and you get 3, right? And so what do we get here, folks? Well, just this part will become a 3, right? This entire piece will just become 3. And so you'll have this original piece right here plus this numerator divided by 3, but that is just 34. 102 divided by 3 is 34, right? 3 times 34 is 102. And 42 divided by 3 is 14. So you get minus 14x here. Okay? And y'all remember this is, I'm just working exactly with what our expression is equal to in the quotient divisor remainder form, okay? And so we're looking good at this stage because this equals to, okay, the x squared has no like terms, but notice right here, this 4x minus this 14x gives you minus 10x, right? Okay, and then we have plus 27, right? Okay, but now let's just show the steps by steps here because this is really cool. You look like maybe you're stuck, okay, right? But this is equal to x squared plus 10x, or minus 10x, excuse me, plus 17 plus 10. And here's again, just you're using that result twice, which makes it a nice competition problem in my opinion. Okay. Now we know from our work right here that x squared minus 10x plus 17 is equal to 3, right? This entire piece right here is equal to 3, and so this is equal to 13, our final answer. Again, to me, just a majestic problem, and I'd like to congratulate whoever thought of this. Okay, that is the solution, folks. 13 is the answer to this problem, and really it contains, just right here is enough. Just this part right here, the given is a problem in and of itself. Noticing that 36 plus 10 root 11 is 5 plus the square root of 11 quantity squared. That gives you a nice clean square root and then some standard sort of algebra right here. Okay, so again, a problem within a problem. I still can't believe it was a junior level problem. And again, a fascinating problem. The answer is 13. Let's write it down right up here. Okay, good night.